Hello guys, today I'm just doing a basic past paper walkthrough for the exam board Oxford International AQA examinations. This is an International AS and A-level paper for physics with the code 9630. So this is a paper 1, meaning that this is a mechanics and materials paper. In addition, this is a specimen 2018 paper. If you guys have enjoyed the video, please do like, share, subscribe to the channel. It really helps a lot. And yeah, let's start with the video. Alright, so the time allowed for the exam is 2 hours. And the materials you need for this paper is a pencil, ruler, calculator, and a formula booklet. Now the formula booklet will be given to you guys in the exam, so just remember how to use the formulas. The instructions are here to use a black pen, so do keep that in mind, and the total marks for this paper is 80 marks. So the first question, section A, answer all questions in this section. So question 1. Gliders can be launched using a machine that pulls a rope attached to the glider. Figure 1 shows the forces acting on the glider at one instant during the launch. So we can see that there's a figure 1 here, and we can see a nice little diagram showing the lift force, the force from winch rope, the weight, as well as the drag force. We can also see that there's a ground level that are present. Now the combined weight of the glider and the pilot is 6,500 newtons. Question 1.1 states that show that the magnitude of the resultant force acting on the glider is approximately 6,100 newtons. Okay, so we have to show that the resultant force is approximately that. So we have to consider two values for this question. So we have to consider the force at which they act. So what we're going to do is we're going to subtract the horizontal forces and we're going to subtract the vertical forces. So we can find out how much is the resultant force horizontally. So if you check it out horizontally, you have 7,200 newtons, which is the force from the winch rope minus the drag force, 1,200 newtons. So if you guys put this in your calculator, you're going to get 6,000 newtons that's moving to the right. Sorry, 6,000 newtons. Yeah, 6,000 newtons moving to the right. Now we have to look at the vertical forces as well. So if we look vertically, you're going to do 7,500 newtons minus 6,500 newtons. Now if you plug these values into your calculator as well, you're going to get 1,000 newtons that's going to move upwards. So technically the glider is going to fly upwards to the right with a force 6,000 newtons acting horizontally and 1,000 newtons acting vertically. So we have the values here. So what we can do is we can show the values here. So as 1,000 newtons, and horizontally we can see that there's 6,000 newtons. Based on this, now we have to show that the magnitude of the resultant force acting on the glider is 6,100 newtons. So what do you need to do? It's very simple. You just need to use Pythagoras theorem here to find out what the hypotenuse is. So this just showcases, let's say, the resultant force. What do you want to find out? So it's a right angle triangle, so we can apply the concepts of Pythagoras theorem. This is the resultant forces. So we know Pythagoras theorem is the hypotenuse, which is squared, which is equivalent to the height squared plus base squared. So your resultant force is going to be the square root of your height, which is going to be squared, which is 1,000 newtons squared, plus the base, which is 6,000 newtons, which is also going to be squared. All I've done is I've just moved the square to the right hand side. So we're just simplifying it quickly. The resultant force, if you do this in your calculator, you're going to get a value of about if you look at it, 6,082.76. So what you can do is you can round this off to about, let's say, two significant figures. So meaning that the resultant force would automatically become 6,100. So like we said in the question, it's equivalent to that. So we are showcasing that the resultant force is equivalent to 6,100 newtons. Okay, so let's move on to the next question. Alright, so question 1.2 states that we have to determine the angle from the horizontal, the resultant force that is acting on the glider. So we have to understand this question. How this works is that we draw the triangle again, the right angle triangle here. So we have 1,000 newtons, which is going vertically upwards, and we have 6,000 newtons going horizontally. And we can see that the resultant force, and we had to find out the angle. So using the concepts of SOHCAHTOA, we know that this is a trigonometry type of question. we have to understand where we have found out our resultant force as well to be about 6,100 newtons. That's resultant force in this case. We have to know this is the hypotenuse. This is, let's say, the opposite, and this is the adjacent. Now we're using these ideas is because we're finding out the angle from the horizontal of the resultant force. So meaning we have to connect the angle between the resultant force and the horizontal. So indirectly this becomes the opposite. This becomes the hypotenuse and adjacent. So we have to use, I think, TOA, which is tan theta, which is equivalent to the opposite divided by adjacent. So if you, let's say, rearrange this to find out theta, which is the angle, you're going to get tan inverse of the opposite. Alright, we're just rearranging the formula. The opposite, which is 1000, divided by the adjacent, which is 6000. And since you do that, you're going to get the angle's value to be about 1000 divided by 6000, and you're going to get roughly about a value of 9.46 degrees. So this is going to be somewhere the answer. You can round this off to 9.5 degrees. So this is going to become 9.5 degrees as your answer. Alright, this seems to be, yeah, this is correct. Okay, so let's move on to the next question. Alright, so question 2 states that an engineer tests a car by measuring the time taken for it to travel 1,500 meters at a constant speed. When delivering its maximum output power of 35 kilowatts, the time recorded is 28 seconds. Now, question 2.1 is asking us to calculate the magnitude of the resistive force that is acting on the car. So we have to understand which formula we use for this situation. So we can use on the formula sheet, we can see that we know that power is equivalent to the change in work done divided by the change in time. We have another formula where power is also equivalent to the force times the velocity. We also know that velocity has a formula of distance over time. Now, since we are given the distance and we're given the time recorded, we can indirectly find out the velocity here. So we know that velocity is equivalent to the distance, 1,500 meters, divided by the time, 28 seconds. Now, find out the velocity first, okay? Once we find out the velocity, okay, that's going to be 53.571. We know the velocity. Now, what we can do is we can find force from this equation by rearranging force to make it the subject of the formula. So we know that force is equivalent to the power divided by, let's say, the velocity. We know that the output power is 35 kilowatts. So the first step is we're going to convert the kilowatts into watts, and we know that 1 kilowatt is equivalent to 1,000 watts. So indirectly, we know that this makes 35 kilowatts the force, which is going to become equivalent to 35 times 1,000 watts, which will make it divided by the velocity, which is 53.571. We're going to equate this. The reason we're doing 35 times 1,000 is to convert it in terms of watts. So that's the reason why we multiplied by 1,000 on the top. 53.57. If you find out the answer for this, the force should be equivalent to 653.3 newtons. You can round this off to 650 newtons, or you can leave it as 653 newtons. This should be alright as well. So 653 newtons. Do show all your working. It's very important that you guys show all your working for 2 marks for this question. Right, so question 2.2 states that identify one way in which the engineer could modify the car so that the time to cover the distance, the total distance, test distance, is reduced. So what we can do is the engineer can somewhat streamline the structure of the, or let's say streamline the structure of the car, or let's say design a new engine with a greater power output. So what the engineer can do either is to streamline the structure of the car, or maybe he could design a new engine for the car with a greater power output. So in this case, we're just going to stick with streamlining the structure of the car. That'll make the total test distance to reduce, or the time taken to cover that test distance will be reduced in that case. Let's move on to the next question. Now, a neutron decays by emitting a beta particle. Identify the other particle that is emitted in the decay. So this is very important that you guys write this down. It is an electron antineutrino. So the wordings are very important that you guys understand this. This is an electron antineutrino. Describe what happens the electron and a positron collide. I think this question needs to be rephrased correctly. Describe what happens when an electron and a positron collide. So you need to describe that they annihilate and annihilate. So they are emitting 2 gamma photons. So you can just write these words down for 2 marks. That should be better. Alright, so let's move on to question 4. Is that a radioactive nucleus decays with the emission of an alpha particle? You gotta describe the changes that occur in the proton number and the nucleon number of the nucleus. So the proton number is going to be, let's say, the proton number down, which is going to be 2. The nucleon number is going to be, let's say, 4. So you can leave it as, you can put maybe negative 2 as well, or down negative 4 as well. That should be alright as well. Compare the relative penetrating powers of alpha and gamma radiation. You can say that, you can show comparison, but don't allow a simple list. So you can say that the gamma is greater. That should be alright as well for 1 mark. And next question is, the gamma rays from a point source are traveling towards a detector. The distance from the source to the detector is changed from 1.0 meters to 3.0 meters. Calculate the ratio. So in this case, we have to use the inverse square law. So we have to understand how the inverse square law works first. So we know that the inverse square law for Y radiation, or is I is equivalent to I0 divided by R2. Okay. So we know that. So what we need to do is we have to write down the distance changing, right? So we have I divided by, which is 1 divided by 3 raised to the power of 2. It's going to be 1 divided by 3 raised to the power of 2, which is going to be 9, which is 1 divided by 9. This is 0.11. That's going to be somewhat your ratio. And in this case, you can calculate the ratio. Intensity of radiation, that's given. And the intensity of radiation at 1.0. So it's somewhat, this is the ratio format for about 2 marks. You can leave it as a decimal as well. Doesn't matter. As long as you leave it as a fraction or decimal, it should be alright. Spectacle lenses may be tested for shock resistance by dropping a small steel ball onto the lens as shown in figure 2 and then checking the lens for damage. So we can see that the mass of the steel ball is 16 grams and the height of the drop is 1.27 meters. Okay, so we have to calculate the speed of the ball just before the impact. We have to ignore the effects of air resistance in this question, so you don't need to include any form of air resistance here. That should be a good thing. Now, based on looking at this question, we have to decide which formula we use in this question. So we have to understand that we can use maybe the formula of v square, which is equivalent to u square, plus 2as, since we have to find out the speed before the impact itself. So the speed before the impact would be, we know the mass of the ball and we know the height of the drop. So the mass of the ball, which is going to be 16 grams, and the height at which it's dropped is roughly 1.27, right? So using these two values, we can somewhat plug this into our equation. We know that the initial velocity would be 0, so indirectly meaning that it's going to be v square is equivalent to 0 square plus 2 times a, which is in this case 9.8, the acceleration, times the height, which is 1.27. So we're just going to put this in brackets, so it's much easier. So going to be v is equivalent to square root of 0 square plus 2 times 9.8 times 1.27, all in brackets. Put the brackets. It's really good when you put in brackets, so it's easier to understand the question. So it's going to be square root 0 square plus 2 times 9.8 times 1.27, which is going to give you a value of about, the speed before the impact is going to be 4.98 meters per second. Now, the reason we give acceleration as 9.8, since we know that acceleration's value due to gravity is 9.81, so we can leave it as it is. So the speed before the impact is 4.99, meters per second. We're just rounding it off to two significant figures. Actually to one decimal place as well. Two significant figures are much better actually. So this is, by the way, this is 4.989. You round it off to 4.99. Round it off to to three significant figures actually. That would be better. 4.99 meters per second. Okay, the test ball bounced back to a height of that. Calculate the speed of the ball just after the impact. So we have to understand the speed of the ball just after the impact. We have to understand is that gravitational potential energy could be equivalent to the kinetic energy that's lost. So meaning that whatever gravitational potential energy you gain is equivalent to the kinetic energy that's lost. So we can look into the idea of combining two formulas together to get the speed after the impact. So what we're going to do is that we know that mgh is equivalent to half mv squared. So if you look closely, we can understand that the height, it bounced back with the height of that 0.85, is that we don't need to use this formula. We can use the same formula again. The velocity is equivalent, v squared is equivalent to u squared plus 2as. So v is equivalent to the square root of 0 squared, since the initial velocity is 0, plus 2 times the acceleration 9.8 times the height, which is 0.85. Right? In this case, they gave us the height here in this case, so we can plug these values into our calculator. So we're going to get, let's say, 4.081 meters per second. So this is the speed after impact, so it's going to be 4.08 meters per second. This is going to be your speed after the impact. Okay. Calculate the change in momentum of the ball due to the impact for 2 marks. We know that the change in momentum formula is going to be equivalent to change in momentum is the P1 minus P2. So here in this case, we know that the change in momentum formula itself is mass times velocity. And we know the mass here is 16 grams. We have to convert that mass first. So 16 grams has to be converted. We know 1 kilogram is 1,000 grams. So the mass in terms of kilograms is going to be 16 divided by 1,000. 16 divided by 1,000, which is going to give us a value of about, let's say, 0.016 kilograms. So that's your mass. So do write your mass first. Very critical that you guys write the mass first down here. So we know that's the mass, and now we have to find out the change in the velocity, or what I mean by is, the change in the velocity in this case. So we know that the change in momentum is going to be the mass 0.016 times the change in the velocity, which is 4.99 minus 4.08. Now the reason why we're doing two subtractions here is that the ball could bounce back. So when it bounces back, it could be moving towards a negative direction. So it could be in the opposite sign. That's why we're doing 4.99 minus 4.08. So indirectly, your change in momentum would be your mass, okay, which is 0.0616 times 4.99 minus, because they're in the opposite direction when the ball bounces back. So we know that it's going to give us a value of about 0.1451 kilograms meters per second. So if you round this off, it's going to become 0.145 kgs meters per second. This is going to be your answer for about 2 marks. Hopefully you guys understood that when the ball bounces back, it could be moving back in the opposite direction to when it was falling down towards the ground. Okay, so let's just take a ball falling downwards and going up, bounces backwards. So the falling down we can consider to be as positive, or you can consider it either way as negative or positive, as long as the signs are opposite to each other. Alright, so let's move on to the next question. Now the time of the contact was 40 meters ms, okay, which is I think what is ms? I need to check. Okay, leave that. To calculate the average force exerted by the ball on the lens during the impact. So what we need to do is we need to use a formula in this case. So I'm just going to try to search what ms means. Ms just means milliseconds. Sorry guys. So this is milliseconds. So 40 milliseconds. The time of contact was 40 milliseconds. Calculate the average force exerted by the ball on the lens. So the formula we can use here is that the force, which is equivalent to the change in momentum divided by the change in time. So using this concept, we know that the time of contact was 40 milliseconds, and we have to convert milliseconds into seconds. So seconds, and there's a formula for that, is that 40 milliseconds could be equivalent to, let's say, a 1 millisecond. 1 ms is equivalent to 0.001 seconds. So based on that, we know that the time is going to be 40 ms times 0.001 seconds. We have to get this in terms of seconds. It's very important that you guys convert the values first before plugging them into the equation. So time is 0.04 seconds. To calculate the average force, we know the force is equivalent to the change in momentum, which the change in momentum we have found out is 0. From the above question, we know that it's 0.145. So 0.145 divided by the time, 0.04 seconds. Now, I want you guys to plug these values into your calculator and see what answer you guys get. So you're most likely, if we plug this into our calculator, get 0.145 divided by 0.04 seconds, which is going to give you an answer of about 3.625 newtons. So this is going to be 3.63 newtons. All right? Okay. Explain with reference to momentum why the test should also specify the material of the solid that blocks the lens it sits on. So we can mention that the solid block, it may deform, okay? Since it deforms, we know that this would affect the, let's say, it might affect the rate of change. It would affect the rate of change of momentum of the ball, right? Of the ball and the force itself. So we can mention for 2 marks is that since the solid block may deform, it would affect the rate of change of momentum. Okay. Oh wait, we have to mention momentum, rate of change of momentum of the ball and the force itself. Okay. Of the ball and the force itself for about 2 marks. So that's the reason why we're explaining why reference to momentum, why the test should also specify the material of the solid that blocks the lens that it sits on. So the solid block will deform and it would affect the rate of change of momentum. So this keyword rate of change of momentum is very important of the ball and the force itself.